Yeah, and then you can minimize the screen.
How do I minimize?
Did you press F11?
I did.
Well, you can just, yeah. Right, there you go. And please click the hide.
All right, guys, time has come. Please have a seat. Thank you. Please have a seat. Come on, guys. We're a bit upsetting. All right, so thanks for coming. So the YouTube, the broadcasting already started. So today we have 3 speakers. It's very exciting me because I don't have to speak today. So it's easier for me. All right, so we have the implementing a FIDO or a FIDO?
FIDO.
Yep. So we're implementing a FIDO flow by Brian, and after model demystified by Jurgen, and the OCR use case in the logistics industry with Microsoft Quality Services sounds very fancy, but Gordon Lebu coming from all the way from Singapore. So today we have 3 speakers, and I hope you guys enjoy a lot. And we have a picture still remains, right? Yeah. And we have the free drinks and the restaurant outside. And you don't have to excuse us to go outside, just go outside, but please do not take any phone inside the room, so that please respect the speakers. All right, it's all yours.
Cool. Hi everyone. My name is Brian Boyd. I'm working at BitFlyer here in Tokyo. Came over here from San Francisco temporarily to learn their code base, and then heading back to SF in a few months. So while I've been there, one of the projects I've worked on is a FIDO2 project. In this case, it was a 2FA project for one of our existing applications. FIDO supports both 1FA and 2FA. So what I'll present today applies to both 1FA and 2FA. Also, my company, BitFlyer, supports Tech Talks. So we do Tech Talks every week. So this is a modified Tech Talk that I gave at BitFlyer. So FIDO2, web authentication, and CTAP2, enabling true passwordless logins. So FIDO2 supports both 1FA and 2FA. So the project that I implemented was 2FA, but 1FA is the true passwordless login. And that's the stuff that will probably revolutionize how we log into computers over the next 2 or 3 years.
What FA is for?
Factor authentication. Yeah. So quick history of FIDO. So both FIDO and FIDO2 managed by the FIDO Alliance. FIDO and U2F, which is the 2FA version of FIDO, was created by Yubico and Google working together. That created this U2F spec, but that wasn't quite enough to get us to 1FA. So the next step, Yubico worked with Microsoft in order to further the FIDO spec, and also worked with the W3C in order to get this WebAuthn moving forward. And so the combination of the FIDO2, CTAP2, and WebAuthn is what creates FIDO2. And in all of the in all of this work, strong public key cryptography is the key. So the YubiKey itself, which looks like this. Sorry, people online, but it looks just like this. This is one. It's a tamper-proof piece of hardware that itself holds a private key and is able to generate public-private key pairs. And to be clear, FIDO2 is only about authentication. So it's not a competitor to OAuth 2. In fact, it can simplify interacting within the OAuth 2 flow. And to be clear, FIDO2 has nothing to do about a token. There's no token involved with FIDO2. During the FIDO2 authentication process, you basically are returned a yes or a no. And that simplifies things on many different levels. So you don't have the fear of having a token leaked as a security problem and other things. So to say this again, there are two types of authentication. The first factor allows you to log in, and the second factor simply double checks that it really is you. And the way that security works when we're interacting with computers is that we work to authenticate you by working with something that you have, like an authenticator, something you know, like a PIN or a password, or something you are, like a biometrics. So any security solution that you see being created will try to come up with a clean way of working, of integrating these three different factors of authentication. So what is the process of authentication? First of all, it's associated with an existing user. So you don't use, so with FIDO2, you're not creating a new user. You're enabling the authentication for this user on your system. So you have the user, it exists, and then you can use FIDO2 in order to ease the authenticating of that user. It involves a recognizable proof, but a recognizable proof in a form that can't be readily guessed or copied. So maybe some random GUID, something like that. And it can be encrypted when it's sent. So and it involves a dialogue between the server side, also known as the relying party, and the authenticator, which is the YubiKey in this case. There are different forms of hardware authenticator. For example, on your Google phone, or probably on your iPhone as well, you have a piece of hardware that will act as a authenticator. So basically, this dialogue is kicked off involving this recognizable proof that's part of this dialogue with the authenticator. And if it succeeds, then you're authenticated. So it's a fairly straightforward flow that is highly secure. It's that sweet spot. It allows us to simplify the login process while providing a higher level of security. So how does FIDO2 work? There are two separate flows. In each case, as I said before, the application user already exists. And the application may implement support for first or second factor authentication. In either case, the flow doesn't change. You have a registration flow and you have an authentication flow. Yes.
So when you say application user, is that like Azure AD user? What is application user?
It could be an Azure AD user, depends on, but typically, like for an application we have at work, let's call it admin web, we have computer support users. So they're in the staff table. And each person in that staff table would be considered a user. So in that case, associated with that user, we have a username and password because the application I created is 2FA. However, if you implement 1FA, then within that table, all you do is have a registered user. You have this existing user within your system. And to maybe clarify, I think maybe the root of your question, the data involved with the FIDO2 is stored in a different place, typically in a different place than the data of your application. And it's stored within a much more secure, at least as secure, probably more secure location. For me, I created an Azure function using cores and Cosmos DB, and making sure that only this one application is able to access this one Azure function. But that just didn't really give much details in how it works. This is more specifically how the external authenticator flow works. It's similar for your hardware, like you'd have on your laptop or on your phone. In this case, I'll just spell out how it works for the YubiKey. So, as I said before, it works because of the magic of public key cryptography. A public-private key pair exists for each user credential. So when you've registered, this public-private key pair is created for that registered user. And only the authenticator uses that private key, and the FIDO2 server only uses the public key. So the authenticator is it's this tamper-proof prover of I'm really who I am. So the server side encrypts data, encrypts a challenge, sends it to the authenticator. The authenticator then decrypts it and is able to say, I understand this, and sends that response back to the server, and the server goes, okay, you understood it. Great, I'm going to let you in. So is it okay if I walk?
Yeah, sure.
Okay.
You want your hand mic?
Yeah, sure. So just do a quick walkthrough. So the application, the user goes, I want to log in. And so the browser receives it and sends a request to the FIDO2 server going, I want to log in. And the FIDO2 server goes, okay, well, you have to satisfy this challenge. So sends it to here, to the browser. Browser goes, oh, it's a challenge. I know what to do with that. Sends it up to the authenticator. The authenticator receives the challenge and signs it using the private key that it has associated with that user. And the YubiKey, this is also an important part of the process. The YubiKey signals to the user to tap the key to prove that a person is there. It's a subtle but very important part of the process, because the user has to be present at that computer for it to log in. You can't have any sort of remote hacking going on with this. And all it is really a simple tap, and it's able to recognize that tap.
When you say tap, where to tap? The tap of the device?
Yeah, it's interesting. See that? The Y? There's a Y there. Yeah. It starts blinking. So then you just basically touch it.
I understand.
And then it goes, okay, great, thank you for that. And then once tapped, it sends it back down here to the browser. The browser then creates a form and post and sends it back to the application. And you need to do this. You can't just send it directly here, because otherwise you have a security hole at this level. You could, I mean, you're basically just going, okay, you're authenticated here, and just allowing it to be. So if you sit down here and then allowed it to be responded back, that'd be a security hole. So I don't have the JavaScript to show it, but it would be pretty clear if I did show that. So basically, you send it to the application. Then on the server side takes the credential response and sends it back down to here and goes, okay, this is what the YubiKey says. What do you think? Is it valid or not? It then runs it through its validation process and then decides if it's valid or not. If it is valid, then it returns true to the application. Then the application logs in.
So in reality, step one is kind of going to the right first and then down to the FIDO server, not directly between the browser and the FIDO server through the application once, or not?
So step one is displaying a web page.
Step zero.
Or I'm sorry, yeah, the first step is step zero.
The actual step one there.
Yeah, and then the actual step one is sending a request down to here. So depending on if you're doing 2FA or 1FA, that request looks a little bit different, but not radically different. All of this flow is the same whether it's 1FA or 2FA.
How does the application know that it's waiting for authorization if you're going through directly the FIDO server first?
Well, the application is responsible for displaying or making this JavaScript code available within the browser. And then when it's displayed, there's an event that occurs on page load or whatever that then instigates, that kicks off the login.
I see.
So any data that this needs is pre-populated at the server level and populated, so it can be populated here in order to make the proper request there. And this is the overall architecture. So I'll talk a little bit more about what the different parts are. So CTAP1 and CTAP2, these are protocols for working with the external authenticator. But it's the web authn that needed to be implemented by the major browsers in order to enable this FIDO2 functionality. So Firefox, Edge, and Google Chrome all support it. And it's enabled by a very simple API. I believe it's Navigator API to make the calls out to here. And just to make it clear, you don't need to use WebAuthn. You can use a platform authentication API that goes up against the internal authenticator. It's still a FIDO2 flow. It's just not leveraging WebAuthn, but it's still the same request response involving public-private keys. And on the server side, you have the server-side app, and it interacts with a FIDO2 server, which itself is a wrapper around a FIDO2 library. So in order to implement this, you have to have an implementation of the FIDO2 spec on your server side. So there currently exists implementations for .NET as well as Java. So that covers most of it. They're in preview, but they are being heavily tested. And I think the version for .NET has been embraced by, I think, the .NET Foundation. So it will be getting lots of resources to make sure that it is fully battle hardened. So these are the components of the basic flow, and just wanted to mention this quickly. The external metadata services, it's a way of validating that the authenticator that you have doesn't have any known hacks available to it. So if for our implementation, we only allow one authenticator. So we'll keep track of whether that's been hacked or not. So we'll know. But if you're in a company that is, allowing this to be used throughout your workforce, then you're going to want to allow a wide variety of authenticators. And the metadata services are a way of validating the metadata of the authenticators to make sure that the authenticator hasn't been hacked. So it's an optional feature to include within your flow. Depending on your use case, you may want to implement it, or it may not. Bang may not be worth the buck. So if you're serious about a FIDO2 flow, definitely consider external metadata services, but also recognize that they will, it's adding a lot of complexity as well. And they don't necessarily have the most recent ones. So if your workforce likes to use the latest and greatest, that could be an annoyance to them. So once again, what are the components of FIDO2? The authenticator, tamper-proof, FIPS 142. I did some research on that, and that is the most secure form of hardware protection that's available commercially. So that's what you'd hope to have for something that that you want to depend on for 1FA. Web authentication is a W3C standard. It's embraced by the major browsers, CTAP2. That's what was the real guts of the FIDO2, working in conjunction with WebAuthn, makes FIDO2 work. Server-side FIDO2 library, like I mentioned, you need to have an implementation of that, but we have implementations for Java and .NET, metadata service, and strong public key cryptography. Those are the building blocks of FIDO2. I included these details to help people if they're thinking about implementing. It goes into a lot of detail that probably isn't that interesting to us for this talk. But we can refer back to it if anyone has some detailed questions. So I mentioned that the flow was the same whether you have 1FA or 2FA. And so what makes the two different flows different is the configuration that you pass in when you start a particular flow. So one is user verification. Let me drink some water. So do you want to use a PIN or biometric to unlock the authenticator? This is typically used for 1FA. And there are 3 different values that you can provide. The values are designed to fail nicely. So they're not looking to cut you off or make your life hard as a developer, but they're designed to make it straightforward what is required, and if it doesn't match, there's a graceful failing. There's a graceful failing that occurs, and you'll know pretty quickly if your configuration doesn't work for what you're trying to achieve. So the next one is attestation. This is where you compare the metadata from your authenticator with the latest from the authoritative metadata service. So you don't need to do this, but if you want to, then you're able to. And notice that one at the bottom, no attestation statement will be returned. That's what we use because, again, we have one piece of hardware and we will track whether it's been hacked or not. Best practices. So even if you don't do the metadata attestation, you should still store the verbatim attestation object. And what that does, it gives you a history of these attestation objects so that, over time you have these guys and then you change an authenticator or maybe you add several more. It allows you to then go back, maybe historically, when you find an authenticator that has been hacked, you can then go back to these stored attestation objects and find out when you were first exposed to this potential hack. So it's just good security discipline. So within the YubiKey and other authenticators, allow registering more than one credential per account. So you can, within an authenticator, it itself can hold multiple credentials, but you can also have, for this one user, multiple authenticators. So that's just supported by the FIDO2 spec. It gives you flexibility within the workforce. If someone works for two different people and they have two different demands or two different types of accesses, then it allows you to work through that. Again, weigh the pros and cons of requiring attestation. I already covered that. Review and enforce security and privacy considerations. There are different ways that you can lock down security. So, for example, the authenticator can generate its own public-private key pair. That's one way of doing it. Or on the server side, you could have your own public-private key generator coming off of a particular, I think, CA, and so certification authority. And so that way you can track who gets what. So if you have different applications, each application could have its own CA. So that's another way of tracking security. And there are pros and cons of that. Do you want to take on that added complexity? There may be an advantage to it, so consider that. We're getting near the end, so just wanted to mention token binding. Token binding is a way to make sure that any information that is shared across a TLS connection can only be used on that particular connection. So even though FIDO2 doesn't use tokens, it does share some information. And so another way, and that information is encrypted, so it is protected. But if you want to be extra careful, token binding is another layer on top of that you can then use to add security to protecting that FIDO2 flow. And provided references that I found useful and you may find useful as well. Questions?
One of the basically means you need to have an additional form of authentication, be it a key or be it biometrics authentication. And what then does 2FA mean in this context?
So for us, we had a 2FA for our application, and it was entering in a PIN. So it's like they would enter in their username and password, they'd go to another page, and then they'd have to enter in a PIN. Or it could look like going to your Google Authenticator or Microsoft Authenticator and having it connected with that, where you enter in a one-time password. So you have to read data from your phone and then type it in there. That's kind of annoying, especially once you've experienced the FIDO2 flow. Because basically with the FIDO2 flow, you pull out your key, you plug it in, because it is 2FA, it is post password, login. So you enter in your username and password, but then with your key plugged in, your Y just starts beeping. You just tap on it, and that's all you do. You don't have to enter in you don't have to enter in any information. The tap is all that you need. So the key and the tap.
I think you can also, you said you could use it for first authentication, and
Mhm.
I think that was the case that you were talking about. In that case, it can also then require another role on top of the press
Correct.
pin.
Correct. Or even biometric. So any combination of what you have, what you know, what you are.
You mentioned that it is running for the web in your browser as a JavaScript library.
Just JavaScript code that calls down to the server and interacts with the authenticator.
How does the browser talks with the USB port?
That's WebAuthn. That's the beauty of WebAuthn. It makes it very easy to access that. They're basically, there may be one or two methods that are exposed, and I wish I would have brought the JavaScript code, but it's easy enough. You can find the JavaScript code online within the references. Everybody pretty much does it the same way. And I believe it's navigator.credentials.git, if I remember correctly.
All right, so the YubiKey,
Yes.
the reason why YubiKey, the one FA,
Mm-hmm.
is that the tapping actually it's not the biometric, right? Just tapping.
Right, but you can. There are keys that do have biometric, but this YubiKey Series 5 does not have biometrics. But it does support PIN.
Mm-hmm.
So for 1FA, basically for 1FA, you don't do the username and password, but it requires you to tap it. Then when you tap it, it pops up a form that will ask you for a PIN. But you can that's configurable within what you pass in when you instigate the flow.
Right, so if you insert the key, if you just tap, it's 1FA. And if that the tapping is the biometric, if that's considered to be 2FA.
The biometric would then be the 2FA. Either the biometric or the PIN would act as the 2FA.
Okay,
But but if you trust a YubiKey, so that you could have just it flows. It doesn't have that 2FA. So that's a choice. I think most people would want either the PIN or the biometric as a second factor.
Right, because otherwise, if Jim stole my key, he can log in at me, right?
Mm-hmm.
But that's why we have to have the PIN or biometric to make sure that that key is my correct username and password.
Kind of, yeah. I like the idea of going back to what you have, what you are, what you know. And if you can get two of these, then that's a very secure form of login, much more secure than simply the what you know, which is
How much is
username.
that?
I think 50, $60.
Mm-hmm.
So 5,000, 6,000 yen
For the key?
per key, yeah.
Okay, so when can we see the SP.NET web application to implement FIDO authentication? as a developer, it's easier to see the code.
Oh, sure. Actually, if you go to the FIDO2 GitHub site, you're able to you can run that and look at the JavaScript and see how it runs.
Okay, so good for the next meetup. Or any other questions?
This is FIDO2, and if I'm reading correctly on here, only YubiKey version 5 supports FIDO2, not the previous version 4, right?
Correct.
So is there a FIDO1? Because I have a YubiKey here, actually. It's a version 4.
Yeah.
And I've been using it with just the tap for the second factor authentication. So that's not FIDO2 then.
It's not. It's that's you actually that's U2F.
Oh.
Yeah.
Five.
Which is pretty good. I mean, it works pretty good. But to really like enable the passwordless login, it needs to support FIDO2 because with U2F, for example, it doesn't store the private key on here. It actually sends the public private key encrypted down to the server and stores it there and then sends it back. Whereas with FIDO2, it actually stores the private key on this key, which is a more secure solution. I mean, when the public private key is sent down in FIDO1 or just FIDO, it's actually encrypted using a private key on this key that can't be read. So what is sent down can't be read on the server side, so it can only be read once it's sent back to here. But FIDO2 is about storing the keys locally on the YubiKey. I know it's probably more information than you asked, but thought I'd clarify that.
Makes me want to keep
Yeah, and actually, yeah. If you buy them in bulk, they're much cheaper too. Give it to your friends.
Thanks for your presentation. Please give a big applause.
Cool. Thank you.
All right, so even though we still have a bunch of questions, we need to move on to the next step. So who is going to, if you go next up, we're going to next. Yeah. And you guys are sharing the this, right? Okay, there you go.
Oh, 1 second.
Is there a client implementation in that next?
Is there what?
Client implementation in that next side?
Not yet. But that, I mean, I'm working on that to get it more into our work environment as a whole. So I'm working with security because I think it's needed.
Okay. So as we discussed last time, we got a presentation on the actor model, and some of us had some questions. So I de facto volunteered to dig a little bit deeper into this, to try to better understand what this actually is and what this actually does. Today I would like to go into this from a little bit of a historical perspective of why this exists and how we can use this today, or how this is useful for us today in our current environment that we might face. So just a little bit about me. My name is Jurgen. I'm from Germany. I spend quite a lot of time in Asia, actually, but in Tokyo, I'm just here as a tourist at the moment. I've been around IT in various roles since 2000. And I started to refocus on IT and entrepreneurship in 2015. I do enjoy looking at various things from unconventional perspectives to see what can be done there, and I like to try to solve them. This is for me something that gives me joy. However, a lot of times when I actually write some code, it feels a little bit like on the left side here. For example, when we go into really complex problems where we face like parallel programming and things like that, it's oftentimes just a bad time. So let's look at this in more detail and see what we come up with. So one of the terms we discussed last time was concurrent versus parallel. Where exactly is the difference, and how does it differentiate? So when you actually look up the definition of which I wasn't aware back then, it's quite a simple thing actually to understand. So when we look at the beginning from where we came from, we had like one core that was our CPU, and back then it was a very, very sequential thing. Systems that we coded, they were pretty much deterministic because the output of these things, there was just nothing left or right that could influence us in any way. If you think about it, in a sequential system, if I would have a bottle here and I would look at the bottle and I would determine the bottle is there, and then I look away and then I grab the bottle and I know where the bottle is. Once we get into more, once we advance through the history of computing, we start ending up more in such scenarios where all of a sudden we can have like hundreds of threads that play with our world. So in such a system where we might have to consider a lot of threads, a lot of actors in our system, it can very much happen that I look at my bottle, I recognize the position, and then Ken comes, grabs the bottle, and when I want to grab the bottle is gone, and that's it. So when we now look at this definition of concurrent versus parallel, essentially what concurrent does is, let's say we have two same tasks, right? Let's say the left side of this wants to do something, and the right side of this also wants to do something, but in between we also want to do something else, whatever this might be. So we might switch back and forth between these tasks, so we kind of handle the control over, and we can do them de facto in parallel, but not in the real sense of parallel. For example, let's take this example of building a wall. In a sequential manner, I build my first wall. The first wall is finished. I move over to the second wall and do the second one. In a concurrent one, I start building my first wall. Then I go to my second wall. Then I lay another brick on the first wall, and so on and so forth. Now, in a parallel world, this then just happens 2 times sequential, because I can split my workload up into simultaneous execution. It halves my execution time if I have the resources for it, and then I just build my wall quicker. So where is this coming from? Like I initially showed, we saw this kind of very, very old CPU on the side. This thing basically had like one core, and initially what we had was an increase in frequency, where we just could scale up through frequency, and this way we could handle our workload. Now, at some point, this idea of ever increasing the frequency started to break down because of some physical issues there. We had to like pack more and more transistors on there for density. We had the closer we come to it, the more frequency we try to achieve, the hotter this thing actually gets. Unfortunately, I haven't found this chart again. But if, for example, if we would try to replicate performance of this in a single core, we would have to put in an enormous amount of energy to do this with actual frequency. So what happens is, but we just start packing on cores, and these cores basically allow us to increase our performance by lowering off the frequency at the same time. If you've seen how modern CPU infrastructures work, if you look at any of the kind of Intel chips, if you run them in a single core configuration with a very, very low loadout, they can scale up to 4 gigahertz, for example. But if you then require all the 20 or 40 cores or what you might have on there, they will regulate itself down, because the heat that is generated on these chips They simply cannot produce this high frequency anymore, so they have to regulate this off. So when we see now in what kind of environment we are in and what kind of jobs we have to do, we find ourselves in environments where we have virtual environments, where we have distributed environments across networks, across CPU sockets, and all of this requires us to apply a certain shift in thinking how we want to tackle our actual problems in programming. So the actor model in itself is it's a conceptual model of concurrent computation. It specifically aims for concurrency. And in this model, everything is an actor, just as in object-oriented programming, everything is an object. We have three operations that are allowed for actors that were defined back then. This model comes around 1972 or 1973. It was created. So every actor can create another actor, which becomes a child. Then we can send messages between each actor, which is a very important concept, because this kind of is like the core behind this idea, which I will go into more detail later. And then we designate how to handle the next message that comes in. Each actor has an address that we can address to, and we also know from where our messages came, so that in theory we can reply back. But the way this actually works under the hood is it's more of like a fire and forget thing. So you fire off your message and it arrives at an actor, and then this thing, this unit, this computational unit does something with it and reacts to in whatever way there is defined on. Another important thing is that it's essentially every actor has one state in itself. So it's a private state that's encapsulated in its own unit. So when we look at this, how this actually looks like, this whole thing in itself is one actor unit. So it's
The green area.
yeah. So
Which whole thing?
yeah, so you need to take this message box and this let's call it compute unit, and this basically is an actor.
So
Maybe let's take this.
Okay.
So you have an address here, so you know how to address this unit or this batch, and then your message comes in. These messages can be addressed in an async way, but once it gets in here, it switches into a synchronous processing. So it's a FIFO queue and first in, first out, but it can only process one message at a time. So, one second. So when we go back to this one, we can see that we get this delivery of messages in, and then we process it in some way one by one. And then once this processing is done, the next message comes in, and then we give back the control of, or we respond to something if we need to respond. By default, these messages compared to, for example, like in a classical TCP/IP setting, they do not send an acknowledgement. So they act more like a UDP. When you send a message over UDP, you will not get any feedback back if this message was delivered or not. This basically accomplishes that. This is a more performant way of handling this.
Yeah.
Yeah.
Is there a way of tracking like via observability or some other approach to knowing like when things fail? So like, because typically if you're sending a message, you want that message to be received.
Yeah. I would say there are a couple of ways you can do this. So by default, as far as I understood it, there's no way that the message is it doesn't feed back if the message is received or not. Mm-hmm. But the way this is built is that this system basically spawns these kind of actors in a tree-like way. And if, for example, this actor down here would fail, it will signal back to the supervisor that it failed, and then the supervisor can spawn this actor again. And in this way, it can self-heal the system as they describe it. So this is one of the key features which often is pointed out in this actor model, that it has a certain fault tolerance. And that it can fail under the assumption that we simply cannot know all the possible ways a system can fail. And that's why we can just let it fail. And instead of like crashing the entire thread or the entire process of this thing, we just let this one actor fail. And then it goes back up, and then it gets handled from the top down. And well, yeah, you have to implement what you want to do with it. So I already went into this. Again, what's important is we do have, every actor has one address, and you send your messages in, it gets persisted in state. So even if this actor starts failing at some point, it can spawn back up, and these messages can keep pushing in, but they get queued on, and then once the actor is back there, as far as I understand it, it keeps getting processed. So the information basically doesn't get lost. Feel free to correct me on this. This is still a little bit vague on me, but this is how I understood it.
Are you going to talk about how the supervisors are designed?
No.
Okay, that's cool.
Okay. Yeah. So as I said before, it gets up and does synchronous message processing. And what's important here, this unit in itself, it doesn't need to wait for responses from other actors. It just can keep processing messages. And the way you would design such an actor, as I read it, you would design it in a domain-driven setting. So you put in your state and your logic that would encapsulate that actor, so that you can do all the work that you need to do inside this unit, and that you do not need to rely on any kind of other units or actors outside of this.
So I'm sorry, it's not a workflow.
Yeah, basically the workflow happens inside
it's
the unit.
Within one act.
Yes, yes. And what makes this thing essentially race safe or thread safe is that one actor runs in one thread, and you cannot access the state from external in any way. So you cannot, like in an OOP setting where you could just where it could happen that two requests try to alter one shared state at the same time, and then you have this race condition, and then you have a problem. This simply cannot happen here because there's no shared state, no shared memory, no nothing.
Did you, quick question, did you run into the concept of item potency at all?
No. Do you want to add to it?
Item potency just means that when you run a function, given the same input, it provides the same output.
Pure functions.
Pure functions.
Okay. I thought I would call it deterministic. So I expect something. It's always the same output.
Yeah. Just different words for the same thing.
Yeah.
So I think that it seems to me that would
help keep the system consistent.
Yes. So I guess I'm not, I mean, we all would try to argue that object-oriented programming in a parallel setting should also be deterministic, but it cannot be guaranteed. I mean, there can always be errors in some way that can creep in. So this is what this actor concept tries to prevent. And yeah, it makes you put 2 in, and when you expect 4 out, it's always the same output. That's what it tries to prevent. I mean, you can screw it up. There's always the possibility of screwing it up somehow, but it puts a certain safety behind. Okay, this we already had, but I think you want to add something to this. So basically, you always start up with one top-level supervisor that you call off, and that one then triggers the children underneath, and these supervisors then handle how these actors behave, or how they basically they ping the health of the actors and see if they are still alive or not. And again, this helps us to achieve fault tolerance or self-healing. Do you want to add something to this?
Do the supervisors act as like smart factories?
Smart factories.
So it's like created if it need be, like. Sure. Sorry. I'm really interested in actors lately, and so like there's this, like the supervisor, it seems like it acts as a kind of factory.
You mean like a load balancer kind of thing?
Maybe, or like creates the actors if the actors failed. If it needs a new actor, it creates the actor.
Yeah, like a Kubernetes, right?
Yeah,
yeah.
Make sure that there's something there to handle them.
This is actually a question that I kind of asked myself as well, and I couldn't answer this yet. So if you think about an actor here that has to do a workload, these actors kind of, they do not have like a, they can have long-running tasks, they can have short-running tasks. We as programmers might know it, but we do not have any kind of determination of what they're actually going to do, because they can do what they want. So what I ask myself is, how do they actually reside in the system? So when we say you can spawn child actors on this off this thing off, what happens when the load gets too high on one actor? Does it actually like add additional actors on or not? I guess you could try to figure this out somewhere in the call stack or in the thread view in an IDE, but I haven't looked into this. So if anyone has any idea about how this actually works internally or under the hood.
Well, given the example of Akka.net, which I presented on last time, this is what you can do with it. It's not like quite the miracle that you might think it is. It's basically like when an actor fails, before it fails, it tells its supervisor, I failed. And the supervisor, and this is how I failed. And the supervisor can decide what it should do next. And the choices are resume, restart, stop, or escalate. The last one being pass it up the chain to the next person to decide what to do with it. And those are basically the 4 choices you get when that actor goes awry.
Okay, so that means there is like no, what we just wanted to.
Nothing as complicated as that. Purely just react to what happened. Nothing complicated like load balancing or anything. That you'd have to do yourself. You could have the actor tell his parent like, "Hey, I'm in trouble here. Like, can you help me out?" And yeah, that's all like domain specific stuff that you could do. But the base stuff you can do already within Akka.net, which is the one that I know about, is you could say, if it's this exception, you can go ahead and continue. If it's this one, then stop. If it's this one, then restart. If it's this one, I don't know. I have to ask mine.
Okay. Good. So where can we, where does the actor model actually makes sense to implement? In my opinion, it's something that needs to be used selectively and cannot just be thrown across the whole system. So for example, if you would have something like transactions, where you might have to, where one transaction part fails in one actor, you might have to reverse others, you could implement this there. So if you have like a customer that comes in, then you have this order processor sitting in the middle, it kind of inquires. So it first might reserve the order in the system and then comes back, and then it requires, does he have the balance in that? Yes or no. In a case of no, it sends it back, it takes the order or gives the order back or frees the order back up. And if it says yes, then it just goes through and says, okay, order processor, do your thing, take the money out and give the order to the customer. In this case, an actor model would make sense. If you have things like batch processing for example, in image processing, where you go from one filter that you have to apply to the next filter and so on and so forth, you could also employ an actor model that when one fails, it goes back up and reverts all the changes if it fails. One of the things where it really becomes interesting is obviously in distributed systems. If you put it in the architecture, due to its fault tolerance and due to its self-healing state, if you ever constructed systems that spawned across networks into multiple nodes, you know that network communication has a certain amount of error in it where it always fails. And the more nodes you have in the end that you have to communicate with, the more problems you will have. And in this case, an actor model makes a lot of sense because it just kind of skips over these, or it kind of ignores these issues with network errors and kind of corrects them. There are some issues with it. Deadlocks is one, however, I tried to read into it. It's not something that happens often. So you could have a state where at the same time two actors try to write into a pipeline, and then it could produce a deadlock, if I understood this correctly. Another one is it can produce message loss, and due to the nature of the system, this message could be gone and nobody really knows about it. The other thing that came up is the overuse of actors, that you just go overboard with it and try to design your whole system around the entire actor model where it might not be useful. In realistic scenarios, if you look through a program that you code, you should look into where you actually need like flow that is rather synchronous. And once you get to parts where you might require this kind of concurrency in the system or parallelism, then you should use a certain programming paradigm that kind of fits this. So looking at the problem first and then trying to figure out what might make sense or not. And another thing is this kind of dynamic actor generation in highly distributed systems. If this goes out of control or if there's an overuse for it, this can just in the end produce a performance hit. Now, those are things I think I never really actually used it in any kind of production system. So it's very, very hard for me to actually judge how often these kind of things occur or not. Maybe, did anyone actually ever use actors in production in any way? So what do you think your issues are that came out in production systems when you use them?
Well, the biggest issue for me is debuggability.
So what?
Debuggability.
Okay.
It's really hard to, if you're trying to find out where something went wrong and you don't have a good actor framework to work with, then it's not like you can just follow the stack trace back to where the problem occurred. You've got to figure, oh, this message came from over there, and this message came from over there. You got to sort of take that extra step to trace back the flow through to debug.
Okay.
So it's like, it sounds like you really want to have a very clear observability approach, like make sure that you're doing proper logging, proper tracing, things like that. And with one system I worked on, it wasn't actors specifically, but it was a similar approach. We made sure that we could follow a message via an ID, even though it like transformed into different looking messages as it went through different actors. It still had this unique ID associated with it that could then allow us to trace as it went through the system.
Okay. Yeah, I mean, this sounds a little bit to me like I experienced it in microservices where when you send your messages across and then this thing goes into a different pod or service essentially, when you say it's very difficult to debug this, kind of sounds a little bit similar to me. So yeah, I guess once you incorporate a logging strategy for that, this might help. But then again, I guess there should be tools for it that can be used for logging in this sense.
Yeah, if you have a good one, then come with it.
How many more slides do you have?
Sorry?
How many more slides do you have? How many more slides do you have?
Oh, no, I'm finished. Very soon. Okay. So just to leave it with that, working on multi-threaded multi-threaded environments or multi-core systems, as Herb Sutter put it, is a little like learning to swim by jumping into the deep end. I guess if you ask any developer, it's just not a simple thing, and it requires a lot of planning and figuring things out that they just in the end run smooth, because otherwise you're going to sit there for days, weeks, and months and try to figure out where things went wrong. Okay, thanks.
Cool.
Questions?
Thank you. Yeah, and because we don't have enough time, sorry, we don't take any break. If you need to go to the restroom, just go ahead. But all right, so next up. And I want you to mute here.
Sorry, if you
I'll just give it to you.
yeah, sure. Could you unmute yourself?
And I give you exactly. All right, and please share your screen. You can share from the screen. Yeah, okay, that's it.
Even in that here too, in case you want to do that. It's like her leg. Right. But otherwise, you can just customize it.
All right. And it's HDMI. And did you share the desktop? Yeah, in the green. Okay. So, all right. And please speak to this microphone. Okay. It's quite slow. And please hide. Click the hide. Hide. Huh? And did you unmute your mic? Did you unmute? Yeah, I think so.
Let's make sure, because the last time we did not get any voice, which is okay. Yeah, okay.
All right, let's start.
Yes. Hello, everyone. Okay, so I'm Chun from Singapore. So same as the second speaker, also travel here. First time to Japan. Thank you. So yeah, just now both of you share a very technical, deep down discussion. So from this my presentation, we are more from the business side. Okay, so I'm actually working in a startup called Audio, which is a logistic firm. So in the next few slides, I will share with you what is the problem and how are we going to use .NET and also Azure technology to solve it. And as you can see, it's basically about OCR. Okay, so this is my name, Chun. You can just call me Chun. I'm not from China. Okay, I'm from Singapore, but I'm Malaysian. I'm currently working as a CTO in Audio, and those are my tools. Basically .NET, JavaScript, and also recently picked up Golang. So anyone interested in Golang here? Who? Okay, let's talk later. So this is my Twitter. Please follow me. Don't have a lot of followers, but yeah. And I have a blog and a website that I keep on updating frequently. And today I have a teammate, which is also Singapore MVP. So he's a AI and Microsoft MVP. So part of the project is actually done by him. So if later I have some question that I cannot answer you, I will deliver the question to him. Okay, so this is Twitter. And he's actually going to US to participate in the Microsoft build. That's why he can't make it for today. He cannot join me, so I come here alone. Okay, so today's agenda for my topic is about these three things: custom vision from Azure, computer vision from Azure also, and the keyboard. Okay, so I have the code uploaded on the GitHub already. So for those who have computer, can access it. Don't worry, I will upload this slide to the Meetup later, so you can access it as well. So Audio is a logistic startup. What are we trying to solve is that how can we deliver the containers, the physical container, not the software container, the physical containers on the Singapore land side efficiently? How can we make sure there are always trucks delivering containers on the road instead of running it empty? That's how they earn money. Yeah, so this is what we try to solve. And this is the system that we built, and we are trying to digitalize the whole industry. So the current logistic situation in Singapore, I'm not sure about Japan, but in Singapore, it's still quite manual. So a lot of things on paper, pen and papers. So there's no computer. They have to communicate via walkie-talkie. They have to communicate via WhatsApp, or even just a phone call, email, so on. So what are we trying to solve is reduce this kind of inefficiency in the workspace. So that's the first thing that we need to solve. How do we make our system understand the paper? And that's why we need the help from Azure to do the OCR. So this is our app. Actually, it's a demo app, but you can play with it now. It's available in the GitHub link also. You can click it and you can access the website. So this is how it looks like. Maybe I skip the presentation and go to the. Yeah, so this is how it looks like. There's a page, there's a section for you to upload the image. For example, this, and let me choose one, the handwritten one. Okay. Upload. So what it does is that at the background, you will start to analyze what are the handwritten text, and then you will show it at the right side, and then you will try to understand what are the printed text and translate it. It will take quite a while. So I go back first. It's quite slow. Yeah, it's all English, especially for the handwritten analyzer. if I read it correctly on Azure website, it's currently still in preview and only they accept English for now. So yeah, it's come out already. The accuracy is not really that great when your handwritten is actually quite messy, but I can adjust the level over here. And then this is the handwritten that analyzed by the two services under computer vision. So this under custom vision and this. Oh, sure. So this is the one. So let's compare to. Still not that bad. Yeah. So this is the thing that you can play around. So the first tab that you see is that there are a few sub images. What are they? Actually, they are coming from the custom vision. So you can log into customvision.ai and try out. So what we need to do, and this is what my teammate Marvin is doing, is actually doing the training for the images. So basically, upload all the forms that he can file in our daily operation. Then he upload it, upload all of them, then mark them individually. So to mark which are the texts are handwritten, which are the texts are printing. So this is how he did. There are a few hundreds of documents that he always upload. Then from there, we will do an iteration on training. So the tool will get more and more accurate when time goes by. So if you go into the GitHub, then you will see this .NET Core project, which I can show over here. So they are basically under the key thing to take note is under the services folder. There are a lot of interfaces here, but this is for dependency injection. So the tag and analyze service is the first one that we see just now. The first one, tag and analyze. So what it does is that you will use the custom vision API and with the documents training, then you will try to predict what are the areas are handwritten. Then you will crop the images out and then analyze what are the text inside using the handwritten recognition service. So the handwritten recognition service actually is the from the computer vision. There is actually just an API that get called. There's a tricky part in this computer vision from Azure is that when we first try, we always thought that when you call an API, you accept that you get the result immediately. But actually for this, it's not. It will take some time to analyze the text. So that's why there's a for loop over here. The while loop over here to wait to check whether it's actually still analyzing. Only when it is finished, succeeded, then we will return the result and show the images that you can find. And actually, it's quite funny that when I try to run this for a few times with the same documents, it always return me a few different a few different outputs. So sometimes you will analyze more, sometimes you will analyze less. Okay, so this is the thing that I haven't figured out why. Maybe you can share with me later. Okay, the third one is actually the OCR. There's an OCR service under Azure that you can directly use, and this is the most simplest one that you can find. And the code is very straightforward. Just calling it, and it will return you a JSON format that can read the position and the text at the position. So by using this, we can then able to figure out what the form is about. We know what the form is, then we will know the value of the field from the paper. Then we will input into the system. But sometimes, from what we figure out now is that it's not really 100% accuracy. For example, you write ABC, it may translate to ABD. So there still need to be a second double check on the value itself. But actually, it's more simpler instead of asking human manually check it. Okay, so there's one thing that I would like to highlight is that during this project, There's another thing that suddenly I come to this is called Azure Keyboard. Some of you may know it. It's a key management tool from Azure to protect your key and connection string. Because when I joined the Microsoft event, then I meet an MVP, say, how come there are so many developers still committing their keys to the GitHub? Then now GitHub start to emailing you that you have this vulnerability, keep receiving this email. So actually there's no need to do so. There's a keyboard and there's a C# library available, and for other .NET languages also. So you can just directly use it if you are not still not using it. Don't put it under don't commit the code to the repository. But when I try to learn it, then there's something wrong actually on the Microsoft official document. I'm not sure whether you can see it. Actually, it's a screenshot because they removed it after I submitted my pull request to the document. Yeah. So what they make a mistake is that there's a thing they need to do is the keyboard throttling, because they do not want you to always accessing the keyboard. Yeah. So there's a limit that you can access. So when it fails, you need to wait for a while, then retry again. But somehow their retry, it doesn't work. It will only run the while loop for one time. So yeah. So don't always believe the Microsoft docs. Yeah. So don't always believe, and let's contribute to Microsoft docs to make it better. Actually, this afternoon I checked it's no longer using the code that I submitted. Actually, it improved a lot more. But now they use a go-to statement. Yes. So I'm shocked. Maybe you can contribute again. It's under this article. You can find it. Yeah, that's it. So because it's running late. So if you have any question or you want to talk to me, please join my Twitter. And this is my project repository. There's a problem inside my code. If you can find it out, tell me. And if you come to Singapore next time, I treat you a meal. Or if you have any issue, you can tell me also. I will buy you a coffee in Singapore. Thank you.
Any question? Singapore.
So how can I touch the OCR? How can I use it?
Test it.
Is that good or is that
Good. Super good.
Did you compare to the other providers?
We'll do it soon. Yeah, we just get started on this project, so we are trying.
But actually, you should test yourself. Actually, it really depends on the configuration. It depends on the original image. And how writing is actually key.
Do you need to train like on a particular form? Like you train on a form and then you do another training on another form, another training on another form?
No, now we just do a bulk upload and train everything.
Oh, really?
Yeah.
Okay, cool.
The purpose of the training is to let the machine figure out what are the handwritten, what are the texts are handwritten. Yeah, that's all.
And then how do you like, because I'm thinking you have all these forms with all of this tags or data names, and then the values of that data. How do you then translate that to something you can store within a data store?
Oh, that one we haven't done yet.
Oh, okay.
Yeah, that part we are just trying to figure out how good it is to understand what is handwritten. That's our first step. Yeah.
Gotcha.
Yeah.
Yeah. Like how do you translate from OCR?
Yeah.
Because that's what you want. I mean,
Yeah.
That's why you're reading it, so you can.
So to reach that step, I think we need to separate the different form for different.
Exactly.
Yes.
No, that's incorrect. The answer is nobody knows this.
Okay, so for the computer vision, you don't need to train, or actually you can train because the model is sort of open. And if you're using the custom vision, you can upload your own image to tag it by yourself and be trained. But this is not for handwriting. It's more like the classification.
Yes.
Right, but I'm thinking about the case that you're doing this to help make processing of these containers quicker. So the data on these forms apply to something like deliver by date, something like that, that you want to use that information within your business. So
Which helps you in your the custom vision?
Which
To distinguish form?
Yeah, it's on the form. So now we are trying to figure out how good it is to understand the handwritten first. If it's good, then we will proceed to do it.
So it's more the classifier, the simple classifier.
right.
So you can use it like the free the classifier before even calling the quality service. And for the OCR point of view, we are supporting 25 languages. And for handwritten, it's English only.
Yeah.
And if you want to running this quality service inside your application, you can do that because we are supporting the Docker content for computer vision only for OCR, and in that case only English. So as long as you try to read English by using the OCR, you can actually run it inside your computer by using the Docker container.
When you say English, do you mean English characters?
English character, yeah. English character. And the handwriting is not containerized yet, so you have to call it the cloud version.
Should acquire design.
I recently saw a presentation from some lady here in Tokyo. She did research at the university, and she had these like very old Japanese characters that were like stacked on top of each other, and it was crazy. And the way she was extracting that information from and the accuracy she received, this was really impressive. So yeah. So when I guess this kind of individuality cloud service probably can't really come close to.
Right. So when coming to the processing your own format, the first thing you want to do is try to figure out the line and the breaks, and once you want to do it better, you can finally pass into the code to realize what the data is. Yeah. So there is a bunch of pre-processing stuff you have to do. Anyways, all right. So thank you for your code stuff. So. All right, so that's everything for today. And what is that? Yeah.
That recognizes dope rubber.
Yeah. Right, and if you want to try the community service Azure, you just go to the try to search the Azure community service under the website. You can just upload your image to see how it is. You don't have to set up anything. Just go to the page, upload the file, done. Very easy to try and easy to demonstrate from our point of view. All right, so let me stop the broadcasting first.